Beginners are often confused by the fact that there are two R pipes. I know this can be super confusing, so in today's video I'm going to show you how both of these works and compare their strengths and their weaknesses. So let's dive in. Now whatever pipe you use, I want to make sure that you don't type it out yourself but use a shortcut instead. In RStudio, you can use Ctrl-Shift-M to throw the pipe that you want to use. By default, this will use the Magritte pipe, but within the settings, you can change that so that it shows you the bass pipe instead of the Magritte pipe. So that way you can save a lot of time by just not typing out these special characters. Alright, so the biggest advantage of the base R pipe is that you can use it without any package. That's super neat, so that you can use pipes even when you don't use something like the tidyverse. For example, we could simulate some numbers, so it would look like this. Then we could round them, so we'd have that, and then we could calculate the mean out of that. This works really easily, and we use the base pipe here. But if we were to take the same code and then replace this with the Magritte pipe and then try to execute this, then we'll see that R cannot find the corresponding function. And the reason why this happens is because this pipe is part of a package called Magritte, so we will need to use the library function to load a package that we need. Most commonly that will be the tidyverse because it includes this package, and then if we try to execute this, we'll see that we once again can execute this. Now for beginners, one of the nice things of the Magritte pipe is that it is less strict. It doesn't force you to use these function calls with parentheses at the end of your function. You could use these parentheses here or not, you'd still get a result. By the way, these numbers here always change because the underlying random numbers will always be regenerated. So just in case you're wondering about that. Either way, you see here that you can either use these parentheses or not. But in the base pipe, whenever you don't use these parentheses, the pipe operator will complain that the right-hand side of the function call requires these parentheses here. So if you adhere to them, everything works fine. If not, then R will complain. So in a sense, the base R pipe is kind of stricter than the Magritte pipe. But I don't think that the strictness is much of a disadvantage, because in the most typical scenario, you also want to fill the parentheses with extra arguments anyway. For example, if you had a data set, then you could just take this data set and stick it into the pipe and pass it to mutate. And in there you could then calculate another column that just calls z is x plus y. So here we filled the parentheses with stuff anyway, so we didn't even notice that we had to be strict with the right hand side having to contain these parentheses here. And of course, in this scenario, both pipes are actually one and the same, so if we stick in the Magritte pipe here, it works also exactly the same. Now fans of the Magritte pipe will tell you that it's really cool to use the dot operator as a placeholder for arguments inside of a function. And they're totally right about this. It is indeed a cool feature, and the nice thing is that nowadays both the base R pipe and the Magritte pipe have a placeholder feature. For example, if you wanted to take this data set and pass it to the LM function to create a linear model, you often don't want to have to stick this into the first argument, but instead the data should go into the data argument. And then you could specify the relationship of that linear model, saying that the Y column should be described by the X column, and then if you execute this, you will get a linear model. So here the crucial thing was to use this data argument here. So this is a really cool feature of the Magritte pipe, and since our version 4.3, the base pipe has something similar. So if we were to take this here and then replace the pipe by the native pipe, and then we have to replace the placeholder by an underscore. And now if we do this, we see that we get the exact same result. And I can already hear Magritte fans saying the even cooler thing about the dot operator is that it can be used multiple times. And once again, they're right. That's super neat. And unfortunately, the base R pipe cannot do that, but there are some workarounds that you can use if you want to achieve the same thing. What we could do here is to take our data set again and pass this to the plot function, where we say, okay, out of this data set, take the X column and the Y column and stick this into the plot function. And then we could also fill the plot function with additional arguments like the size of the points and the line width of these points. And if we try to execute this, we see that we get this result here. Now this works, but isn't quite right. In a lot of settings, this will cause an issue. And you can see this here, that the X-axis label and the Y-axis label contain numbers instead of this stuff that we stick into the actual x and y argument. And the reason why this happens is because this data set is still passed to the first argument of the plot function. But if we wrap this into curly brackets and re-execute this, we'll see that things now look better. Again, in this scenario, it doesn't make too much of a difference, but in other cases, you might get wrong results because of that. So try to make sure, if you want to use this pattern, try to make sure that you also include these curly brackets here. Now, if we were to try the same thing with the base pipe, then things don't work out like we want. We try this, we see that, okay, the brackets are also not supported by the base pipe. Here, a workaround could be to just take this part here and then instead use normal parentheses and in there define a new function where we use the dot as the argument of that anonymous function, and then we stick the same code in there. And then we have to remember, if we try to execute this, we see that, okay, the right-hand side thing isn't supported yet. And the reason why this happens here is because we need to also call this function and then things work out. So this is a kind of hacky workaround that first defines an anonymous function and then calls it like the native pipe operator wants. And here we have used this dot as just an argument name. We could also throw in whatever we want here, but then we'd also have to use this as a placeholder inside the actual function. But here I use the dot so that it is similar to the Magritte pipe. At this point, shout out to Isabella Velasquez, who has taught me this little trick here. So thank you, Isabella, for teaching me about this. Now, some people like to use conditional flows inside of their pipe chains. So maybe something should be executed differently depending on whether some other variable is true or false. And with the Magritte pipe and these curly brackets that it allows, this can be achieved within the pipe chain. But as we know by now, the base R pipe doesn't allow the curly brackets, so we cannot use that exactly. But there are some workarounds that are also pretty nice. So let's check that out. So what we could do is to create a Boolean variable that is just true or false. And then we can create another data set that has the same X column as our initial data set. So for example, we could take our initial data set and then pass this to the summarize function to use the cross function inside of that to iterate over all columns where we just apply the mean function. So that way we get the mean of the X and Y column. But maybe we also want to, depending on whether this duplicate flag is true or not, also calculate the mean of this Z column here. And with a Magritte pipe, you can do such a thing. You could use the curly brackets again to throw in an intermediate block. And then in there you use an if statement that says if the duplicate flag is true, then just take what goes into the brackets and join this with the duplicates data set. And in the other case, just leave the data as is. So here we have used this dot operator to really reuse whatever goes into these brackets here. And now if you execute this whole code chunk, you see that, okay, there is another mean of the Z column. And if we use false here, then we see that we only calculated the mean of the X and Y column, and we don't do this join here. And just to stress the point that you can do whatever you want in here we've actually also used the base pipe because that's my default. But if you wanted to keep it all using the Magritte pipe, you could also use that. Really, it doesn't matter what you do inside of here. The point here is that the Magritte pipe allows for using these brackets here and then throwing in a conditional block like this. Unfortunately, with the base pipe, this isn't possible, but still I've never found this to be a disadvantage because I usually like to wrap things into functions with descriptive names. So what I would do here to replicate this flow with the base R pipe is to just take this stuff here, throw this into a new code chunk, and then first replace the pipes. And then I would take this code here and wrap this into another function. So let's create a new function. Let's call it left join if duplicate. And then inside of this function, we need the first argument to be a data set. And then the second argument can be the duplicate flag, our true false variable. And then inside of here, I can just stick in this if statement. And here I replace the dot operator with that, apply a bit of formatting, also replace this pipe with the base pipe. And then I can just replace this whole block here with just the function. And inside of that function, I can set this argument duplicate flag to the actual value of the corresponding variable. In these kinds of scenarios, I even leave out the argument name to have it more concise. And that way, if we execute this, we see here that right now this thing here is false. So we only see two columns here. But if I set this to true and execute only this part and then re-execute this code chunk here, then you see that it gives you the exact same result as this part here. With that, you should have a good understanding of the strengths of each pipe and the differences between them. If you enjoyed this video, then you might also like to check out some of my other videos in this playlist here. And with that said, thank you for watching and I will see you next time.